Okay, let's do this. Let's do some zero product property, y'all. Let's get it in. Get that notebook, get that big old brain, pen and paper, or a pencil. Y'all know I like pencil. All right, so let's not prolong the time. Hey, y'all, how y'all doing? Welcome back here. So listen, let's jump right into zero product property. In some cases, remember, you'll hear it referred to as zero factor property, but it's the same thing. So let's look at a trinomial in factored form. And we started out, remember friends, we started out looking at it like this. And zero product property is giving us a way to now solve for these variables, right, in order to make this statement true. So if I have this binomial times this binomial, remember it's a factor trinomial here, and I set it equal to 0. What I'm asking is for you to solve is what values can x be here that would make this whole thing 0, right? If this was like, if this quantity was a, and this quantity, this x minus 2 was b, then what am I asking in terms of what can a equal in order to make this true? 0. Okay, on the flip, what can b equal in order to make this whole thing true? 0. So with that theory in our heads, what can the value of this turn out to be to make it 0, and what can this be? If you said -3 here, you're right? Because that would make that 0. And if you said 2 here, that would make that right. And how you could show that is to set both binomials equal to 0 and solve. Now, am I expecting you to write this part down? No, I'm not. I get it that you should be able to see that, and if you do that mentally, I'm totally fine, right? But this is how you can produce the answer, and this is how you can put it on paper. Let's do another one. Another factored form, right, where I want you to solve for the x values. Okay. Same thing. And I think just for teaching purposes, let's just set them equal to 0. Let's just go ahead and do that. Okay. Plus 5 on both sides like we did here. Right? We're going to solve for x over here too. So x is 5. And then you got it. You want to subtract 3 on both sides. You got a 2x equals a -3. And x here equals -3/2, or 1 1/2, however you would like to leave it. Here's your answers. Now, let's back up a bit. Well, not back up. Let's go to another step. So we started out with factor form. Now I want us to start out with, to do some variants here, I want us to start out with a standard form trinomial, where we're going to start to pull it all together, friends. We're pulling it all together. Okay? Now, look at this. Our term is greater than a. And look at our 3 terms here. Look at our 3 coefficients. Yeah, we can factor out something. What can we factor out, friends? We can factor out a 2. So if I factor out a 2 here, I'm going to be left with an x squared minus 10x plus 9 equals 0. And this is factorable. Let's keep going. So now we're going to factor this. I'm going to set myself up here. X squared, x and x. Then I'm coming over to my 3rd term, and I'm looking at, now I could use 3 and 3, but if I use 3 and 3, right, we're not worried about that 2 yet, but if I use 3 and 3, that's going to give me a 3x and a 3x. I'm not going to get close to 10, so it's not 3 and 3. But if in fact you guess 9 and 1, you would be correct. So I'm going to put a 9 here and put a 1 here. You can totally switch it if you want. And it's minus. So this means, right, what are our x values? That means our x values here, because 2 doesn't count, because you can't say 2 is equal to 0. That doesn't count, so it doesn't matter, because we're solving for the variables. We're solving for the things that are unknown. 2 is known, but we know that 2 don't equal 0, so it doesn't matter here. So you would just continue to do it the same way you've been doing it. right? We're looking for the variables. X is 9 over here. X equal 1. Now check this out. I want to show you something where that actually could be the case. We might actually we could have more than one answer where what happens out here could be important. Check this one out. I'll put it right next to it. We have x to the third plus x squared minus 12x equals 0. Okay, so look at what we could factor out. We could totally factor out an x, and then I'm left with x squared plus x minus 12 equals 0. And again, this is factorable, so let's factor it. You keep your x on the outside because we factored that out. So there's x here, there's x here, set equal to 0. What factors of 12 work here, friends? If you said 3 and 4, I agree with you. I'm going to go with 3 and 4. So I'm going to call this one plus 4. I'm going to call this one minus 3. Remember, it might, if you didn't get plus 4 minus 3, there is no like magic bullet, right? You just have to understanding your properties of how positive and negative numbers work when you combine them, the factors of those numbers, right? So I just happen to know for teaching purposes that it should be plus 4 minus 3. But always check that you put the signs right. Now check this out. Now you know you're going to have to do x plus 4 equals 0, and then x minus 3 equals 0. But I could also say here x equals 0. Well, that does make sense. Over here, it didn't make sense. 2 doesn't equal 0. That doesn't make sense, so that's why you didn't see it show up here. But here it does. So you have an x equal to 0, and you have an x plus 4 equal to 0, and you have an x minus 3 equal to 0, which means your answers are going to be 0, negative 4, and 3. Look at the difference, y'all. Okay. 2 more variants and then we're done, I promise. Just 2 more. Check this out. Here's an equation that we can do, but it does not look like our standard form. Remember our standard form for a trinomial, right? It's ax squared plus bx plus c, right? This is our standard form. This should be living somewhere in your notes, friends, right? It's different from our factored form. Remember, our factored form looks something like this, right? Standard form, factored. I'll put that over here so we have that factored form. Now, this is set equal to 14, but we don't want it set equal to 14. This thing is called zero product property. So, right, we have to make this equal to 0, set it equal to 0. And how would I do that? And I think some friends have already figured it out. Move that 14 over there. So if I move this 14 over here like this, boom, right, I get w squared plus 5w minus 14 equals 0. And look at that. This we can factor. Let's go. Okay. That's a w squared, so I got a w here and I got a w here. Now think about my factors of 14 that can work, that if I combine them, I can get a 5. What are those factors? Pause the video if you need to. I got 7 and 2. Hopefully you got 7 and 2 with me. I know you did, friends. I know you did, right? And thinking about this one needs to be positive, so I'm going to do plus 7 minus 2, which means my answers are going to be negative 7 and 2. Notice how we got from here to here. One more. You got one more for me. Y'all got one more in you. You can handle it. I know you can. Let's check out one more variant. Now, this one could look a little crazy, but you got it. You're like, well, how do I do this one? Well, first, what did we do last time? We turned it into standard form. we turned it into our standard form of a trinomial. So I'm gonna make this look like this, or this. Let me say that again. This is gonna look like this. So how can I do that? I think some people are already talking about distribute. So let's distribute. Let's check it out. So I'm gonna distribute this x all the way through, which is gonna give me a 2x squared minus 3x equals 2. And because it's zero product property, that's right, friends, you got to move that 2 on over. So if we move that 2 on over, we now have 2x squared minus 3x minus 2 equals 0. And this is factorable, friends. This is so factorable. Let's do it. So what are the factors of 2x squared that can work? Right, one of them has to be 2x and the other has to be x. And now I'm looking at the factors of 2, which are 1 and 2. Here's the question, right? Where does the 1 and 2 go? And what is the sign attached? If you pause and you click back in to see what I got plus 1 here and I got a minus 2 here because, right, that's going to give me a negative 4. That's going to give me a positive 1. It gives me that negative 3. And now I can solve. Plus 2 on both sides. I get an x plus 2 here. And then if I subtract 1, x equals negative 1/2. Okay? So the goal here, when we're doing zero product property, if I give it to you in factored form, you should be able to do it just fine. If it's in standard form, you then have to factor it, and then you solve for your unknowns. And then you end up with some variance where things are kind of all over the place and scattered. Your first order of business is to change that into standard form, then into factored form, and then you evaluate and simplify that way. Okay, so let's give it a shot, y'all. Y'all got this. So take a look at the group work, take a look at the homework, and as always, if you need any help, I am always here, I promise. So y'all go ahead and be well, and you go forth unafraid, all right?